Hope everyone's doing good today. Let's get into it. Need help with a problem. Oh God. Well, if they only bring one parent, 85 people minus the principal and 2 school counselors, so 85 minus 3. I mean, this is a simple one. We can do it. Um, Wait, so yeah, pr principal, because that's how I remember the difference between the two principals. Because the principal is your pal, whereas principale, I guess, is like for a well, even though the principal is probably not your pal, but there are 85 minus 3 equals 82 seats available for students and parents. If each student brings just one parent, then divide by the one student plus one parent equals 2. 82 divided by 2 equals 41 students can attend, including parents. They bring both their parents, you divide by 3, or if you're expecting a mix, you'd have to split up the 82 seats. And divide some by 2 and the others by 3. All right, that's a simple one, but accounting, I don't know if I'll be able to do it. Let's try. Let's see what the question is at least. Their goal is $16,000 in 3 years. What do they need to initially invest if the interest is 3% compounded monthly? Let's check if they made an entry error first off. One plus 0.002. Where does that come from? Why wouldn't it be 3? Oh, it's R over N. And so the rate over the number of months. So 0.03 or 0.3 divided by 36. I assume that they just did that directly. The power of 36? Wait, NT. What's the T? If N is a number of months, then what's the T? Oh, maybe for 12 months in a year? Oh, the number times. Oh, so N is 12 and T is 3. Okay. 0.6577. So, oh wait, I should have 0.03. I was like, that seems a little low. 14,624. So what's the 0.03 over 12? Maybe that's where they went wrong. 0.0025? So if I input the exact same thing as they did, they made an entry error. I don't know. Fourteen six two four 54. 14,624.54. Wait, that's not 14. 16 is kind of like 14, depending on your perspective, I guess. See what this one is. Ooh. That's an interesting one. There must be some cool sub that you can do with him with this. Oh, I see. I think I see it at least. Actually, why do I keep on doing it like that? I should just resize it in OBS. Actually, that's too big. I'm just gonna copy out the problem. So if we have the integral of root 1 plus e to the 2x dx. Good. I think we do u equals 1 plus e to the 2x, which means du equals 2e to the 2x dx. Applying this u sub, we divide by this, so 1 over 2 e to the 2x root u du. Now we still have that e to the 2x right there that we need to get rid of because this integral is in terms of u, and the x being there is a problem. So let's go back to this and rearrange it. If we subtract 1 from each side, that means e to the 2x is equal to u minus 1. So let's plug this in over there. 1 over 2 times u minus 1 root u du. This integral should be possible. Maybe, do we need a trig sub, question mark? Or we need to do a +1 minus 1 in the numerator, I want to say. So without changing the value of this, we can insert a +1 and a -1, and I think that'll do good things for us. I hope. root u plus 1 minus 1 over 2 u minus 1 du. I should bring the 1/2 out front while I'm at it. 1/2 integral, so we have, oh no, that won't work. Not the way that I was thinking. Because we would need, I want to get a cancellation here, but we would need the -1 to be inside the square root. And we can't get a -1 inside the square root without also putting the +1 inside the square root, and then just kind of, it doesn't help. So a plus 1 minus 1 isn't the answer here. If we did another level of sub, is this a trig sub? I feel like there's a trig sub here. I guess I'll show what I'm looking at here. We don't really have this. This is very similar here. If we did u equals tangent, well, they still have, oh, do we want to do just, oh, we want to do just e to the x. No, but, okay, yeah, I think my initial sub was wrong then. I think we want to do just u equals e to the x. This problem is still slightly different, so I'm not exactly sure. But let's see how this works out at least. 1 over e to the x root 1 plus u squared du. U is equal to e to the x. So we get integral root 1 plus, oh, what the hell am I, what the heck? I just invented a new letter. Call it OTA instead of eta. Okay, so for that, if we do u equals tangent v, du is secant squared v dv. That would give us root 1 plus tangent squared v over tangent times secant squared dv. Root 1 plus tangent squared is secant, just 1. So we get 1 over tangent times secant, which is also cotangent. Secant goes with cosine times cosine. Cotangent is cosine over sine. Hey, Druha. It's been a while. How's it going? You're saying aloha now instead of howdy. You changed. So we have basically cosine squared over sine. We can do u equals, no. Is that, that wouldn't be an identity, would it? I don't think so. Hmm. Shouldn't be that bad. I'm just, whenever cotangent gets involved, I forget things. Trig derivatives. Cotangent becomes minus cosecant squared. Okay. I feel like I did something slightly wrong here. Let's make it Wolfram Alpha's problem, maybe? I just want to see what it comes up with for this last part before anything else. That doesn't clean up too bad. Cosecant minus sine? How do they do that? Let me see if the if I give it the initial problem, it agrees though. Maybe I did something wrong along the way. 1 plus e to the 2x. Hyperbolic tangent or well, huh? What sub do they say? There should be a solution with ln's, which I think is what I am getting here. Usually with the hyperbolic trig functions, they don't have to be done that way. Yeah, like here's the log version right here. So I think I can just figure out that what the heck happened here? Cosecant minus sine. 1 over cosine v minus sine v. If you get a common denominator, 1 minus sine v, or sine v cosine v. Oh wait, freaking dude, cosecant and secant I always get mixed up, and I still have the browser up, don't I? One minus sine squared v over sine v. So that's cosine squared v over sine v. And I guess that's what we have there. Okay. So yeah, I guess we can say that this is equal to cosecant v minus sine v. I worked it out backwards, but it's a little hard step to see, honestly. But if you're willing to go along with it, which, I mean, it could have been a lot worse, then integrals of trig functions. Just, I want to look up what the integral of cosecant is, because who the heck has that memorized? Doesn't seem how I'm used to it. Look at a different website. So the integral of cosecant is, I guess that's the same thing I saw on the other side, but it's ln cosecant v minus cotangent v. And then minus sine v, when you integrate that, it integrates to minus cosine, minus to minus is positive, so we get plus cosine. And then v is inverse tangent of u. What an annoying thing. I almost would prefer doing the hyperbolic way that I wouldn't even know how to do, but cosecant of inverse tangent, I guess you have to make a triangle for that. I should write arctan instead of minus 1. Actually, the value rather, plus cosine of arctan u. So arctangent is an angle. And since tangent is opposite over adjacent, u over 1 root u squared plus 1 by Pythagorean theorem. And so cosecant is 1 over cosine of this triangle. Cosine of this triangle is adjacent over hypotenuse. So cosecant is hypotenuse over adjacent. So ln root u squared plus 1. And then minus cosine of that triangle, which is minus 1 over root u squared plus 1. Plus cosine again, 1 over root u squared plus 1. Just one more layer of unsubbing. You can technically get a common denominator for that too. I guess we should. Okay, ln, getting common denominator, we multiply this by root u squared plus 1 over the same. So that becomes just u squared plus 1 on top. Minus 1 is just u squared. U is e to the x, so we get e to the 2x over root e to the 2x plus 1 plus 1 over root e to the 2x plus 1 plus c. Okay, that one's a bit of a doozy. See if someone beat us to it, because that would be typical. E to the x equals secant. What happens when you derive secant? That's equal to secant x tangent x. I think that does that help? I think they want tangent. Am I getting the Pythagorean identity for this wrong? Secant squared is tangent squared plus 1. So yeah, you would want tangent. Maybe the secant sub also goes somewhere. I'm going to post my thing, though. I am doing the sub u equals e to the x, then noticing that a tangent sub at a second sub with u equals tan v would help. I would recommend going through these two subs and trying the problem from there, but you could also short circuit the thought process and go straight to x equals tangent u. Okay, that person might be right too, but to me, tangents seem much more natural. So I'm still going to add in my response there. Take a look at this one. Why does it take 20 years to load this? Oh god. I want to see the post first. Oh, they didn't add any context. Hey. Man, I should erase this off the board. Okay. Oh, I don't have my rotate image extension on this browser. Well, they have the integral from 0 to 12. This is so messy, dude. Dx over root 169 plus x squared dx again. They do a tangent sub, which seems appropriate. You end up with just the integral of secant. Secant integrates to tangent secant. They unsub. This is a little hard to follow. Why is it over 13 on the inside? Oh, I get it, yeah. $12 is such a mean number. Why would they not give 13? So it'll be a unit circle value. Let's put in the original problem, the Wolfram. Squared. Answer, we should get a whiteboard and stream from the beach whilst getting smashed. That does sound pretty cool. Like given the cinch answer, the final value is 0.85, which is different from what they got. Actually, you can draw a triangle for this, can't you? Tangent of arctangent. I mean, tangent of arctangent should be 12 over 13. Because tangent or arctangent should be defined for 12 over 13. Secant of arctangent, you'd have to draw. They just plug it into a calculator. Let's see if we get the same thing. If we do it the way they're probably expected to in a calculus class. I think their work up until that point is right. tangent arctangent 12/13 times secant of arctangent of the same thing. So tangent of arctangent, we can just call that a wash and say it's just 12/13. Secant of arctangent is a different story. We need to draw a triangle. Arctangent is opposite over adjacent. So opposite is 13, adjacent is 12. I think it's Pythagorean triple. 144 plus 169. I don't think it's, I think it's only Pythagorean triple when 113 is hypotenuse. The more I think about it. I think it's a 5, 12, 13 triangle. So this is just gonna be something random. So it also happens to be Pythagorean triple, I guess. Nope, root 313. Okay. So secant of this triangle is 1 over cosine. Cosine is 12 over root 313. So 1 over that is root 313 over 12. So you get root 313 over 13. What is that decimal? .36. That doesn't match the final answer over here. Wah, wah, wah. I guess let's check their work. If I give it this without the bounds, it's going to make me retype the entire thing, I think. If I want to remove the bounds. And if I copy paste, can you give me... Oh, wait, so yeah, they definitely did... Oh yeah, as soon as I saw Cinch, I should have realized that there's something wrong with this work. So they do x equals 13 tangent theta. Dx is 13 secant squared theta d theta. That's okay. When they sub in... I might have done something wrong on that last integral problem. I don't remember. I have to remember. But I'm just going to focus on this right now. So the advice I gave, I don't think was bad because I verified it with Wolfram Alpha. It was just the work that I did for just like see it that might have had an issue. Anyway. Thirteen over 13. What is wrong with that? Oh, wait. When you derive secant theta, you get this. But when you derive this, you don't get that. They just mess up the integral subtrig functions. I didn't even question it, but they're going the wrong direction. They derived secant theta and not integrated it. The integral of secant theta is ln secant x plus tangent x. Ln secant x plus tangent x. Okay. I divided 648 by 4 because there are 4 cubes. No idea where to go from there. Oh, that's a little bit tiny. The 4 cubes might just be a... Oh, you probably do need it for the proportions. Rectangular prism surface area. Two times all the areas. That makes sense, actually. Okay. It's be a nice little exercise. Okay, so basically, three-dimensional rectangle is called a rectangular prism. And this one, it's divided up into four seemingly equal cubes. I think we're safe to make that assumption. And they don't actually say it, but it'd be mean if it was anything else. This is a horrible three-dimensional drawing, but just bear with me. Basically, if these are all cubes, all the side lengths should be equal. If we define, I don't know why I'm doing curly brace, but if we define that to be length, this to be width, and that to be height, well, these are cubes, and all the sides have to be equal length. So we know immediately that width is equal to height because it's a cube, and so these are each 1. W equals h. Over here, we have 4 of the cubes all stacked in a row. So the length must be 4 times the width, or height. And so we're going to use these proportions to work out what the volume must be. Hey, Storm 2 Pain. Level question we can give you. I'm pretty good with stuff that's calculus and below. If it's above it, like differential equations or linear algebra, I can sometimes get it, but it gets a little bit like spotty. For this question, though, if we know the surface area is 648, and the equation for surface area is 2 times basically all of the areas of each face, length times width, width times height, length times height, so all combinations of lengths and widths and heights. We can start plugging in this relationship that we have here and solving for the what the dimensions are. So it seems convenient just to use this, well, let's get everything in terms of widths, sure. So you know that length is equal to 4 widths, so let's put a 4w there for L. W is just w, then we have another w there, then h is equal to w, so I'll put a w there. We have another L, so that's 4w, and h is just another w. And then keep on combining. So everything is now in terms of w, so let's combine everything on the inside. 4w squared plus w squared is 5w squared, plus 4w squared again is 9w squared. Divide each side by 2. 3, 2, 4 is equal to 9w squared. Divide it by 9. Is that going to give us a clean number? 3, 27, 54, 6. 36? Good. Clean numbers. Take the square root of each side and we get w equals 6. I'll look at that in a second, Storm 2 Pain. Okay, so if we know w, we know that height is also 6. and length is equal to 4 times that, so 24. Now to work out the volume, we know we have everything we need. Width times height times length. 24 times 6 times 6 is definitely a number. Um, 24 times 6 times 6 is 864 cubic centimeters. Okay, sorry, I just wanted to get that train of thought. I'll post to this person in a second. Entertaining exercise for you. We have a function f, which is c1, f of 0 equals 1, and for all x in R, f prime x plus f of x less than or equal to 0. The question is to compare f and e to the negative x. I'm not sure exactly what to do with that question. If it's just an exercise, I prefer to just help people have actual like homework questions. I'll sometimes do like math for fun if there isn't anything out there, but I'm not really sure where I would go with that problem. Yeah, I'm sorry. I prefer to at least like try and look for questions people are like actually trying to get help with. Um, this person did post an answer, but I kind of want to post my answer still because I would express it in a different way that maybe works for the person better, maybe not. The prism. Is fine for what x, f minus e to the negative x is greater than or equal to 0. Yeah, honestly, I'm not good at those types of questions. What the proportions are. When I solved it, I mean, I can look at a solution quickly, but like I said, I prefer to like try and find questions that people are trying to get help with. 4 cubes gives guide on what the proportions are. Proportions. Or on the proportions between length, height, and width. Since they're all equal for cubes and the entire prism is 4 cubes, we know that the length, longest side, is equal to 4 times the width, or 4 times the height. Its width and height are equal. We can use the equation for surface area. SA equals 2WL plus WH plus LH. One of the sides and figure out the rest. Uh, Storm, I mean, I enjoy the calculus problems more, but like what I'm trying to say is I would rather like when people are asking for help with their homework and need like the answer to question explained to them. I don't really do math for fun unless I can't find any questions to answer. Okay. Is that a J? Oh, it's a 3. Three x squared minus 27. They find the zeros. Plus 3 and minus 3. It's not shown, but I assume they make a sign chart. Hmm. Not increasing. Let's actually work this out. So wait, there weren't any comments, right? Good. Let me do like get down there. Shouldn't need too much room to work this one out. So we're just going to take their work. This is above. Okay, good. And use it as our own. We found the zeros of the derivative at -3 and +3. And we just need to plug in values on either end and in between to work this out. And actually add it, probably. Well, actually, we know. Actually, okay, that's not work. Well, at the endpoints, we know it's 0 because that's how we got them. Between them, we can plug in x equals 0, and we get. We actually copy down with the derivative. It's 3x squared minus 27. So we plug in 0 into that, we get -27. So in between there, it's decreasing. To the left of -3, we can plug in -4. -4 squared is +16 times 3 is 48. We get a positive number. Past 3, I assume we're going to get minus, but let's plug in +4. Actually, no, it should be plus. Oh, that makes sense for a cubic. So, and right on these 2 points, the derivative is 0, which means it's not increasing or decreasing. And the initial question is not increasing. So I would think we do need to include the endpoints. Unless it means... So I think it sounds like I agree with them then. Let's plug in the original function to Wolfram and see how it graphs it. Maybe there's like some kind of thing that I'm not thinking of. So the peak and the valley are at -3 and +3. But I don't see why it wouldn't be not increasing right at 3. So it should be included. It definitely seems inconsistent to include -3 and not +3. I assume it's a typo, or like whoever gave them that work made a mistake. Ooh. 6 is a simple but fun one. 7. It definitely... That should be true. I wonder how rigorous you need to be, because I would just say, like, by the power rule. Oh, you're saying true for 7? Yeah. The proof part might be a little bit tricky. So probably how you prove it depends on the context of your class. I mean, you could just directly integrate it, though. That seems like the most direct way, or like the simplest way. I'm 5'11". This one over here, you get an equation in terms of A. I kind of want to actually solve it. I was thinking that I was going to give this person a hint and not actually solve it for myself, but I kind of want to see what it's like. Second one, I think you do just integrate it directly and call it good. But I'm kind of curious to see how the first one looks like. So we're going to integrate each from -a to a and set them equal to each other. 3x squared x to the 4th over 5. So integrating that, we get x cubed minus a to a. That we get 1/25 x to the 5th minus a to a. Technically there's plus c's, but the constants cancel each other out. I guess I'm going to say they do. So we get a cubed minus -a cubed. 1/20. What? That's not 25 at all. Less than half of 25. A to the 5th minus -a to the 5th. So that becomes 2a cubed. That's 2/25, a to the 5th. Bring this over to the other side. factor out an a cubed. We can factor out a 2a cubed while we're at it, for good measure. A squared minus 1. So from this term, we get a equals 0. That's not a particularly interesting solution, though. So we're going to throw it out. And they actually say a greater than 0. So we actually can't take that solution if we wanted to. Looking at this one, though, we would get 1 equals 1 over 25a squared. Multiply 25 in square root, we get a equals 5. Well, plus or minus 5, but a is greater than 0. Okay. Well, it works out to be a nice clean number. And of course, I wasn't showing it on stream because I forgot the browser was blocking it. That's the rest of my work, though. How do you not draw a cat or other creature? Because I'm very bad at drawing. That's what keeps me back. Okay. Yeah, I love whiteboards. I just enjoy writing on them. I think he said chalk is better, or is that someone else? A greater than 0. You never get work done on them. Oh, okay. You like chalk because it's less fun. The question seems a bit odd to me. Okay. Hopefully that helps. See what this one is. So I think they misunderstood what the question is asking. Find the zeros of the function, but they weren't asking for that. in the form of x plus or minus a squared plus or minus b. Actually, maybe a and b. That's fine. No, it's not fine, because they use a and b for, like, other things. In the form the answer has. Or, should give them an equation back, not a number, too. Completing the square. Hey, I want to show them an explanation of what completing the square actually is, because that seems to be what the misunderstanding is. Square. It's sort of related to finding the zeros, or it is related to finding the zeros. I should spell out zeros, because I think that's how they usually do it. It is, but exactly the same. Okay.